Look at this image. When a homeowner sees a pipe bursting under the sink, they see a wet, stressful emergency. They do not see a corroded 1.5-inch PVC P-trap assembly. This disparity creates a semantic gap in two-sided service marketplaces. When a layman submits a vague help request like, "My sink is broken," the supply side, the licensed contractors, receive unstructured, unusable data. It forces them to guess the scope of work, which leads to ignored tasks, inaccurate bids, and wasted diagnostic trips. The Snap and Fix Autotasker addresses this friction as a systemic architectural solution. It structures the data at the entry point to ensure marketplace efficiency. It takes the user's non-technical photograph and runs it through a Vision AI model. The system then outputs a highly technical, structured contractor brief containing the exact terminology tradespeople require to bid accurately. Closing this communication gap at the very first touchpoint is the absolute prerequisite for achieving true marketplace liquidity. You cannot match supply and demand if they do not speak the same language. But translating a homeowner's problem for a contractor is only half the equation. The broader architectural intent is to extract maximum financial value from that single initial photograph. We achieve this through cross-module synergy, routing a single user intent into multiple distinct business models at the exact same time. The platform splits into two modules. Left, the service marketplace. Right, the e-commerce platform. From one image upload, a single data payload travels down, splits in half, and populates both the service request and the shopping cart simultaneously. This system utilizes AI as a silent data routing engine to convert unstructured pixels into multi-marketplace gross merchandise value. Let's break down the exact pipeline of how this is executed, starting the moment a user uploads an image from their mobile device. The system generates a holding table labeled Snap Session, running strict file size checks. The image converts into a secure SHA-256 hash. Unstructured data like audio and coordinates are appended. The session locks into an analyzing state before querying the API. Isolating this initial action inside a temporary session table guarantees that the primary marketplace databases are not polluted by failed API calls or abandoned uploads. With the session secured, the backend initiates an API call to a specific vision model, in this case Claude 3.5 Sonnet. The system prompt applies a strict persona constraint, forcing the LLM to analyze the image as a master contractor and a quantity surveyor. The model must output its findings exclusively as a predefined JSON object. It demands a dual-language diagnosed issue and technical description. The model calculates integer values for estimated labor hours and generates an array of replacement parts with search keywords for e-commerce. Rigid architectural constraints and specific data types integrate the LLM as a reliable piece of back-end business logic. When the API returns the payload, the back-end steps in to sanitize it. It strips away markdown formatting and parses the raw JSON object. If the JSON parse fails, or the image is flagged unrecognizable, the session status updates to failed and prompts the user to try again. If the parse succeeds, a logic gate evaluates the urgency level string. If the value returns as an emergency, the flow diverts down a specialized path. This dual execution protocol auto-notifies platform administrators, while injecting immediate safety instructions directly into the user's interface. Embedding these algorithmic safety constraints directly into the data layer mitigates the real-world liability of automating physical service dispatch. With the data parsed and safety verified, the homeowner is presented with the final diagnosis for approval. The moment they tap Post Task, the architecture reaches its climax. The single JSON payload physically splits to execute two distinct database operations. The payload's left half migrates session data into a live task record on the service marketplace, mapping the technical description to define task parameters. Simultaneously, the right half isolates the required materials array, executing a full-text search against the independent e-commerce database. By utilizing the highly specific search keywords generated by the LLM earlier, the system ensures high-accuracy product matching for the exact physical materials needed. In the user interface, this presents as a simple toggle. The homeowner decides whether the contractor will supply the parts or if they buy them to save markup. If the homeowner chooses to supply the parts, they click a single button to add all identified items directly to their platform shopping cart. This specific moment of database divergence allows the platform to manufacture a secondary physical e-commerce transaction entirely out of a service-oriented user intent. We can see the ultimate value of this pipeline by looking at the supply side of the marketplace, the professional contractor. This dashboard shows the interface presented to the professional. It prioritizes the AI-generated technical scope of work and labor estimates, entirely replacing the user's initial vague input. A built-in materials flag dictates the inventory status, explicitly informing the contractor if the client has already purchased the required parts through the e-commerce module. This degree of technical precision gives the contractor the exact data they need up front. They know precisely what tools to bring and can calculate highly accurate remote bids without scheduling wasted diagnostic trips. By systematically removing ambiguity on the supply side, the platform directly increases contractor engagement and bid response rates, accelerating overall market liquidity. We started with a raw, unstructured photograph taken on a smartphone. Through rigorous back-end routing, that image became a highly structured, dual-sided transaction across two distinct marketplaces. This pipeline operates effectively because the generative models are strictly constrained to output predictable, machine-readable data structures. The back-end data routing and schema design provide the platform's primary competitive advantage. In enterprise product design, AI is most effective when it operates silently. As a structural routing engine, it actively multiplies your revenue streams.